look at the okay guys, let's look at the last example on exponential sequences. So there is this question that I found which says find the nth term and the next two terms. So looking at this question, this is an exponential sequence because regardless of the differences that you are going to find, you would find that the first, third, the second differences will not obey any rule based on the previous sequences that we've done. So right away, let's see about the common ratio. So you'd find that 10 divided by 2, which is how we find the common ratio. This should give us 5. Okay, let's check the second common ratio here and see if it's going to be the same. You would see that 50 divided by 10 gives us 5. So you can see that the common ratio between two consecutive terms is the same. So this sequence here qualifies to be called an exponential sequence. And then right away, if you've been making notes, you know that an exponential sequence has got its nth term to be equal to a times t to the power of n, where t is the common ratio. So this formula now is taking up this shape now, which is going to be a times, now our t is the 5, so it's going to be 5 to the power of n, and then we put our tn there. So now the idea is to now find what our a, which is a constant, is. So to find a, we need to pick one term here and put it where there is tn, and then take note of its position and substitute that position where there is n there. So for me, the easiest is always the first term because it's got n equals to 1. So picking 2, we are going to say 2 would be equal to a times 5 to the power of 1. I like rearranging such. This is going to give me 5 times a to give me 5a equals to 2. We are trying to find what a is, so meaning we are going to divide by 5, divide that by 5, which would now imply that our a is equal to 0.4 if you want. So our a is equal to 0.4, or if you want, you can leave it as 2 over 5. But then just make sure that if you get a recurring decimal, just leave your answer as a fraction. That's fine. So having found what a is, we're just going to replace this in our formula there. So it now becomes tn equals to 0.4 times 5 to the power of n. Now it is always a very nice idea to check whether this our formula works and it can generate our terms that we've got. So let's see, when n is equal to 1, let's see if this formula is going to give us 2. It's going to be 0.4 times 5 to the power of 1. You know that this is 2 over 5 times 5. So that and that would divide, giving you 1, and then 2 times 1 gives you 2, which is just the same 2 that we've got. Let's see when n is equal to 2, you know 0.4 is just like 2 over 5, because I'm not using a calculator here, times 5, which is 5 to the power of 2. Now 5 to the power of 2 is 25. If we divide 5 into 25, you are going to get 5. 2 times 5 gives you 10. So you can see that our nth term formula generates all these terms that we've got. So now right away we can use it to answer the next question, which says and the next two terms. So we need to find the term that is going to be there and there. Now if you count the position of this term here, this is position number 4, which means n is equal to 4, and then this is position number 5, which means n is equal to 5. So this is the n that we are going to be substituting in that formula there. So doing that, you are going to say T5 would be equal to 0.4 times 5 to the power of 4. All right, if we do that nicely on your calculator, if you want, you would find that this is going to give you 250. So then it means the term that is supposed to be here is 250. We also now need to find the 6th term, which is going to be T6 equals to 0.4 times 5 to the power of 6. If we do that nicely, we would find that this is going to give you 1250. This gives us 1250. 1250. So if you look at this nicely here, all these, they obey the common ratio rule. If you want, you can say 250 divided by 50, it will still give you 5. If you want, you can say 1250 divided by 250, it will still give you 5. So this kind of a sequence is a very nice one, and I think, according to me, it's one of the easiest sequences that you can come up with and try to find its nth term. So guys, these are the examples that I can put here and give you. If there are other questions that you will meet on exponential cubic sequences, quadratic sequences, and linear sequences, please, you can send me your questions. Then we'll do a special edition to just be answering questions from you guys, students, and teachers. So guys, please, you can like and share my page. I also have a YouTube channel which is just new. If you want, you can go on YouTube, just search for Math Antenna. It's got the same name. You would find my videos there. I'm uploading the videos, the same videos on Facebook, also on YouTube. So it would be nice for you guys to just share and like the page, and then also subscribe to my YouTube channel. So if you are a teacher, you can recommend the page to your students. This is free education. There's nothing, there are no payments or what. It's just me trying to help you teachers, my fellow teachers, as we live in these uncertain times. So guys, thank you very much for taking your time, and watch out for the next topic that will be coming on indices. All right.